The robot standing next to you at the grocery store is not a science fiction premise anymore. It is a business plan with a production line attached to it, and Tesla just put a timeline on it that should make every hiring manager in America stop and think. Here is what most people are missing about the Optimus program. Everyone keeps talking about factory floors, about Tesla replacing welders and assemblers with humanoid machines. That is the easy headline. But the factory is just the training ground. The real target is every job that was designed around a human body moving through a human-built space, and that description fits most of the American economy in ways that almost nobody is saying out loud. Let's start with the number that barely got any attention when it dropped. Tesla has publicly targeted 1 million Optimus units per year in long-run production capacity, with the first production line expected before the end of 2026, 1 million units. For context, the entire United States auto industry produces roughly 10 to 11 million vehicles per year after a full century of refinement. Tesla is talking about ramping a brand new category of machine to a tenth of that scale within a few years of first production. Either that ambition is completely delusional, or the infrastructure behind it is more serious than anyone in the mainstream press is treating it. And here is why you should take the infrastructure seriously. Tesla's edge in this race is not the robot body. Anybody with enough capital can build a robot body. Boston Dynamics has been doing it for years, and it still has not cracked the economic problem of making those machines useful at scale. Tesla's real advantage is the stack sitting behind the hardware, and that stack was not built for robots. It was built for cars. The computer vision systems, the neural network training pipelines, the real-world data collection apparatus that Tesla has been running through its fleet of millions of vehicles on public roads, all of that is directly applicable to a robot that needs to perceive a cluttered, unpredictable, human-designed environment and make decisions in real time. Full self-driving and Optimus are not two separate bets. They are the same bet wearing different clothes. If you believe Tesla's autonomy stack is serious, you have to take Optimus seriously too, because they share the same foundation. Now let's talk about where these machines are actually going, because this is where the story gets genuinely uncomfortable for a lot of industries. Warehouses are the obvious first wave after factories. The picking, sorting, carrying, and inventory management that happens inside an Amazon fulfillment center or a Walmart distribution hub is repetitive, physically demanding, and runs 24 hours a day. Current warehouse automation uses fixed conveyor systems and robotic arms bolted to specific spots on the floor. The problem is that those systems require the warehouse to be redesigned around the machine. A humanoid robot walks into the existing building, uses the existing shelving, and handles packages the same way a person would. No retrofit required. That is an enormous economic advantage for any operator who does not want to rip out their entire facility to automate it. After warehouses comes logistics, retail stockrooms, maintenance work, infrastructure inspection, and eventually elder care and healthcare support. Each of those sectors has the same profile: repetitive physical tasks, labor shortages, rising wages, and environments that were built assuming a human worker would show up every day. The humanoid form factor is not a design choice made for aesthetics. It is a deliberate decision to make the machine compatible with the world as it already exists, rather than forcing the world to rebuild itself around the machine. The economic pressure driving all of this is real, and it has nothing to do with Elon Musk's ambitions. American logistics companies are struggling to staff warehouses in rural areas. Elder care facilities in dozens of states are running short on workers as the population ages faster than the labor supply can replace them. Manufacturing plants in the Midwest are fighting for a shrinking pool of workers willing to do physically demanding repetitive work for wages that have to keep rising just to stay competitive. The companies investing in humanoid robots are not doing it because they love technology. They are doing it because the math on human labor is getting worse every year, and they are looking for an exit. That is why the investment numbers in this space are staggering. Figure AI, one of Tesla's direct competitors in the humanoid space, raised more than $1 billion at a valuation of $39 billion. Apptronik raised $350 million and is actively targeting healthcare and elder care applications. NVIDIA has built an entire foundation model stack specifically designed to accelerate humanoid robot development across the whole industry. This is not a niche research project. This is a global industrial race with hundreds of billions of dollars flowing into it, and the United States is competing against Chinese manufacturers who are moving just as fast and with different cost structures. Here is the honest complication, though, because this story is not a simple triumph narrative. As of early 2026, multiple reports described Optimus production as agonizingly slow and suggested the robots deployed in Tesla's own factories were still largely in research and development mode, not yet contributing to actual production in any meaningful way. The gap between a compelling demonstration video and an economically productive worker is still significant. Dexterity, reliability, and the ability to handle unexpected situations without failing are engineering problems that take years to solve, and Tesla has not solved them yet at scale. But here is the question you should be sitting with right now. Does a technology need to be fully mature before it starts reshaping the economics of an industry? History says no. The first versions of industrial robots were clumsy, expensive, and limited. They still wiped out entire categories of factory employment over the following decades before most workers or policymakers understood what was happening. The early versions of containerized shipping were slow and unreliable. They still remade global trade within a generation. The pattern is always the same. The first wave is easy to dismiss, and by the time the second wave arrives, the adaptation window has mostly closed. So here is the question I want you to think about and leave in the comments below. Which sector do you think gets disrupted first by humanoid robots? And do you believe American companies or Chinese manufacturers are going to win that race? Because whoever gets to scale first on cost, reliability, and deployment breadth is not just winning a product category. They are potentially capturing a share of the global labor market that has never been capturable by a single technology platform before. The shift that Tesla is engineering is not really about replacing factory workers, as uncomfortable as that already sounds. It is about building a general-purpose labor platform that can move through any human environment, use any human tool, and take on any human task that fits the pattern of repetition and physical routine. If that platform reaches scale before society has figured out what to do with the displacement it creates, the economic conversation in this country is going to get very loud very fast. For everyone watching this who wants to stay ahead of what is actually coming for the economy, for their industry, and yes, for the jobs in their own household, subscribe to this channel. We do not cover the hype. We cover the mechanics, the money, and the timeline. And right now, the timeline on this one is moving faster than most people realize.